Hi, I'm James Turner, and welcome to One Take Demos. Today we're going to start a look at Lisp, a language that's near and dear to my heart. It was one of the first languages I ever used. It was a language I in fact used for about 8 years, which makes me somewhat of a pro in Lisp. I started at the MIT AI Lab, and then moved on to Lisp Machine Incorporated, Xerox AI Systems, and then later in my career, Interleaf. So I've, as I said, got about 8 years experience with various versions of Lisp, and I'm glad that you're joining me to take a look at it. It's a fun language. It's a very old language. It's contemporary of COBOL and Fortran, developed by John McCarthy. It's also very nice because it's a very syntactically simple language. There's not a lot of syntactic sugar in it, as you'll see today as we start to take a peek at how the syntax works. Really not a lot to it. It's not like Java, where there's a million things you need to know before you can start using it. So, Lisp is an evaluated language. This is a listener here where you can type in Lisp forms and get back values. I'm in fact using a product called LispWorks for the Mac, but you could pretty much use any Lisp you want as long as it's a Common Lisp implementation. Common Lisp is the ANSI standard, and most Lisps that you're going to get these days, regardless of platform, support it. I chose this one because it has reasonable networking support. Networking is not part of the standard, so different Lisps implement it differently, and I wanted a good one because our eventual project is we're going to build a very simple web server using Lisp. But for the day, we're just going to start by looking at a little bit of what you can do with it. So we'll begin with the basic data types. Numbers are numbers. Right? 12 evaluates to 12. 12.54 evaluates to 12.4. Interestingly, and this is something I hadn't realized until recently, 4 over 6 evaluates, well, to 2 over 3 because it simplifies it. So you can put in proper fractions or even improper fractions, and it will deal with them as numbers. Lisp is very flexible about its number system, and in fact, I'm not sure if the exponent operator works, but let's take a look. So it's 2 to the 20th. Nope, doesn't work. I used to remember what the exponent operator was. Is it EXP? If not, I'll look it up and we'll know next time. Nope. The point I was trying to make is actually that you can... well, I just do something that just demonstrates it just by typing. Oops. Let's make it a real number. Right, we're going to, normally in most language implementations, doing something like this, you'd get back an approximation. In fact, Lisp very happily will deal with it because once numbers get big enough, it starts representing them as what are called big nums, which are arbitrary length and, in fact, stored similarly to strings. So you can deal with very large numbers with high degrees of precision. Anyway, so those are numbers. Strings are, like most languages, double-quoted. And they evaluate to themselves. There's a special concept called symbols. And symbols are kind of a combination of variables. They're places that can hold values. But they also can hold properties that can be associated with them. And they're also a value to themselves. So to specify a symbol, there's two ways, depending on what kind of symbol. You can simply put a quote in front of it. That evaluates to a symbol, and you notice there's no double quotes in front of it because it's not a string, it's a symbol. Whereas this is some number of characters, this is actually a single object, and it's immutable. Symbols are what they are. You can't change them into anything else. There are two separate special symbols, T, which is used for truth, but in fact in Lisp any non-nil value is truth, and nil, which is negative, and also, interestingly, is the empty list, which lets you do some kind of funky programming. We'll deal with lists a little bit later in this. So the next thing you need to know about Lisp is it's a prefix notation language, also known as a Polish notation language, as opposed to reverse Polish notation, which is what like an HP calculator works. So you're probably familiar with doing math like 78 times 4 plus 3, or 4 plus 3, and you remember that, okay, please excuse my dear Aunt Sally, I had to do 78 times 4 first, and then I can do plus 3 afterward. Well, all that ambiguity is taken away in Lisp, because there's never any ambiguity. To do this, you would say plus times 78 for 3. And the way you read this is, it's an operator-operand notation, so the operator's plus. The operands are this one and this one. Whenever you have an operand, which is in turn a function call, you evaluate that before you move on. So the order this gets evaluated is, I'm doing the plus function. Okay, I need to evaluate this. Oh, that's 78 times 4. Okay, come back out and then evaluate 3, which just evaluates to 3. If you wanted to do it conversely, so that you did the plus before the multiply, you would say times 78 plus 3. Right? So there's never any ambiguity as to which operation you do first. That's the entire syntax of Lisp, by and large. Prefix notation, using parens as the separators between clauses, basically, to say here, to indicate the start of a new function call. I'm going to finish up for today with one more data type, which is the central data type in a way to Lisp, which is lists. Lisp stands for list processing, not, as some people say, lots of inane, silly parentheses. Although we used to have a joke at the AI lab that you could tell a keyboard that was used for Lisp because the open and close paren had been worn off on it. So lists are represented, again, you start them with a quote, because if I just typed A, B, C, D, what do you think is going to happen? It's going to try to evaluate the function A, which doesn't exist. So instead we say, quote, A, B, C, D, evaluates to itself. There are operators like you can say nth2 of A, B, C, D. And what do you think that's going to return? I think it's going to return B or C. It's going to return C because nth is 0 based, A is the 0 if location B is the first and C is the second. Now, you may notice that lists look a lot like normal Lisp code that you write, and that's because they're basically the same. Data is program and program is data in Lisp. So one of the cool things you can do is you can actually have programs modify themselves because they can operate on themselves as data. We won't get into that, at least not for a while, but it's something to keep in the back of your mind. So to wrap up our first lesson here, you have some simple data types, you have prefix notation, and you have the ability to operate on lists. Next time, we're going to talk a little bit about function definition, which is where you can really start to leverage the power of Lisp. Until then, this is James Turner for One Take Demos.